We are now ready to consider the data types based on levels of measurement. And that brings us to the question, what are levels of measurement of a variable? You see, the correct statistical method to use to describe or analyze a variable in a data set depends heavily on its level of measurement, which means it is very important for a student to first learn how to identify the level of measurement of a variable before analyzing that variable. And that brings us to the 4 levels of measurement of any variable in data analysis or statistics. The ladder on your screen shows the levels, and starting from the lowest, we start from nominal, next is ordinal, followed by interval and ratio in that order. So to begin with, in particular, you want to note that the first 2 pertain to qualitative variables, and the last, or the upper 2, pertain to quantitative variables. So, for nominal variables, they are data collected, or nominal data. They are data collected on variables that are only used to name or to group. No ranking is involved, and they are the lowest form of categorical data. And all they do is to assign data labels to nominal data, and it is the level of only qualitative data for naming or for grouping. So it cannot be used for calculations. It can only be used for grouping entities. Example, high color, names, labels, favorite foods, yes or no responses. You observe that for each of these variables, if we collect data on them, no group surpasses the other group. Then we talk next about ordinal level of measurement. For ordinal level of measurement, rank or order matters. So talk about, for example, the survey of a product. If we rate it as excellent, good, or unsatisfactory, there is no doubt that excellent is superior compared to unsatisfactory. Ordinal variables cannot also be used in calculations, and it involves both grouping and ranking of data labels. So, for example, if we write the list of the top 5 national parks in the United States, those will involve, the data collected on that would involve a natural ordering or a ranking, or a pay grade, military rank, and so on. Then, we can also talk about the fact that anytime we deal with nominal variables and ordinal variables, again, they only refer to categorical variables, never quantitative variables. So if you know a variable is quantitative, then it can never be at nominal or ordinal level of measurement. Only categorical variables can be at the nominal or ordinal level of measurements. Now, for the last 2, these pertain to numerical or quantitative variables. You see, data at the interval level of measurement have no true or absolute zero. What does that mean? An absolute or true zero should mean the absence of something. So if your bank balance is 0, it means there is no money in that account. That is true zero. A true zero should indicate absence of the quantity. But in the case of interval or variables at interval level of measurement, they have no true zero. Take, for example, temperature. when the temperature outside is 0 degrees Fahrenheit, that does not mean absence of temperature. It does not mean that there is no temperature. So, take note that any variable like temperature, grade point average, birth date year, time of day measured in military time, if we say 00 hours, that just means 12 a.m. It does not mean absence of time. And it is a level of only quantitative variables. Then, for ratio level of measurement, this is the highest level of measurement, and it has an absolute zero. It has an absolute zero, so your bank account balance is at ratio level of measurement because it has an absolute zero. Zero balance means no money, absence of money. And it is also a level of only numerical or quantitative data or variables. So height, weight, if the weight of someone is 0, then that means that person does not exist, or that weight does not even exist. The volume of water used, if it is 0 liters, then none was used, that is true 0. So is assessed value of a house and account bank balance. Now let's test our knowledge quickly. We're to determine the level of measurement for each of the following variables. What do you think? For the nation of origin, well, that will be categorical. If it is categorical, then it is either one of these two, nominal or ordinal. If it just names and it does not rank, then it is nominal, which is the case in this case. Then for 2, you have movie ratings of 1 star through 5 stars. Well, that is categorical, and it is ordinal, since there is a natural ranking structure embedded in the values of this variable. Question 3. Volume of water used by a household in a day. Well, this is definitely not categorical, so it is neither nominal nor ordinal. Rather, it is one of those two, since it is numerical. All I need to check now is does it have an absolute 0? If it's at ratio level of measurement, it has an absolute 0. That is, 0 volume of water, for example, means no water was used. So this is true. This is at ratio level of measurement, since 0 volume means 0 water used. Then what about year of birth of college students? Well, if it is the year 2000 and it is recorded as 00, this 0 does not mean no year. So this does not indicate a characteristic that aligns with ratio. Rather, it aligns with interval, since the 0 is a fake 0. It's not absolute 0. What about the highest degree conferred? This is categorization, high school, bachelor's, master's, and doctoral. Well, that will be categorical. There is a natural order in here, and so that makes it ordinal. Then what about high color? High color in this case is nominal, because it only groups. Then what about grams of carbohydrates in a donut? This will need to be measured and recorded as numbers. Since we're recording it as numbers, it will be at the ratio level of measurement. So this is ratio. Then, for the next example, for each variable, indicate the level of measurement, of data measurement, response to whether or not hockey players scored a goal in the All-Star game. That's going to be yes or no. That is definitely nominal. It is nominal because it categorizes without placing an ordering structure. Then you have size of vanilla chai tea from small to extra large. That is also ordinal because it categorizes and there is an ordering based on size. Then what about number of email messages sent daily by a financial planner? This is numerical, so it has to be a battle between interval and ratio. It is definitely ratio because if it is 0 email messages, then it means absence of email messages sent daily. Then finally, you have the ideal cooking temperature in Fahrenheit or Celsius for a chicken pot pie. Since it is temperature, 0 degrees Fahrenheit does not mean absence of the quantity. So this is a variable that has no true zero. And so it is at interval level of measurement. At this point, we now proceed to the classification of data types based on another parameter, namely time of collection. You see, if you collect data at a fixed point in time, it is called cross-sectional data, whereas if you collect the data probably on a monthly basis, then it is collected at successive points in time, and that will constitute time series data. And that brings us to the point where we define time series data as a set of consecutive data values that are observed at successive points in time. So consecutive data values observed at consecutive points in time. Whereas cross-sectional data is a set of data values observed at just a fixed point in time. To test our knowledge immediately, we take an example. Which parts of this table can we consider time series and which are cross-sectional? Well, this is for sales in thousands of dollars. For a fixed point in time, I observed all of this data for the different cities. So for this fixed point in time, this entire data set constitutes cross-sectional data, which was observed at a fixed point in time. The same is true of this, and then this set, and then this set. It follows that each column of data is an example of cross-sectional data, which is a set of data values observed at a fixed point in time. Then, in contrast, looking row-wise, so let us erase this, and we decide to go row-wise. You observe that if I take the first row, these data sets were observed at different years, consecutive years, or successive yearly times. And so these will constitute an example of time series data. The same is true of the set of data in each of the rows.